master's course is all about what is data science. Right, so that's what we are going to see now. So if you see the word data science, right, so data scientist is supposed to be the sexiest job of the 21st century, bringing in a lot of salaries, right? So the amount of salaries, if you see, it's probably one of the highest in the industry, right, for data science. So people often compare data to oil, right? So data is the new oil, they say, which it has to be processed and information has to be gleaned from the data by applying mathematics or by using computers, right? So that's where this whole idea of computational data science comes in, right? So as Professor Shashi also mentioned, right, when you Google for data science, there are like these lots and lots of ads that come about learning data science. What Wikipedia says is data science is an interdisciplinary field that uses specific methods, processes, algorithms, mathematics to extract knowledge and insights from data, right? So that's what data science means. And similarly, you can kind of use Google search as a proxy for the popularity of certain terms. And if you do that, you will see that the field of study, data science and machine learning, right? So in blue, what you see is data science, and in red that you see over here is what is machine learning. So by about say 2012-ish, there has been an uptick in both the use of data science and machine learning. So this has been normalized with the maximum search volume, right? So if you add in the term Python to the mix, right? So to the mix of data science and Python, you can see that Python has already been more popular than the word data science. But corresponding to about 2012, when the data science starts to pick up, right? So about data science starts to pick up, Python has really picked up, right? So really much more. And the steep growth in the use of both Python and data science. And when people usually ask the question, right, so is artificial intelligence or machine learning better, right? So is machine learning same as AI? Like what the hell is the difference between data science, machine learning, artificial intelligence, deep learning, neural networks, right? So all these terms are out there and then people are really confused, right? So what is really happening? And the purpose of our next 10 to 15 minutes is to demystify this whole notion of data science and where the field lies so that you can make the most appropriate choice for you in either enrolling for our program or what is most appropriate for you, right? So that's the goal for us. And usually if you ask slightly the previous generation of industry professionals or even researchers, they might tell you that AI is a black box, right? So neural network is a black box, right? So is that true anymore, right? So has there been some understanding that neural networks are somewhat like, why do neural networks work, right? So all these things become really, really important. And then I guess in most of your minds, this question is there, right? So should I really study data science or should I study machine learning? Can a data scientist become an AI engineer, right? So what is AI engineering? What is data science? Is AI a subset of data science? So all of these questions must be there in your mind, and that's what we are trying to address here. And the main issue, right, which I see is that we are in the jargon universe, right? So people use machine learning, AI, deep learning interchangeably in conversation, and that trips us up, right? So we have drowned in the jargon universe. This is a fact. The fact is that there are several tools and techniques that a data scientist must know, right? He's expected to know several tools or techniques. But the main issue is that it is really hard to separate tools from techniques, and that causes confusion in people. So let's try to see what is the difference between tools, techniques, and methods, right? So in this context. So the only thing that you must remember is that change is the only constant, right? So tools change very, very fast, right? So C++, Python, TensorFlow, PyTorch, PySpark, Julia. So when I was doing PhD, Julia was not even there, right? So in 2012, 2013, that's when Julia started picking up. At that time, if you said, right, so in around 2007, 2008, when we started, at that time, if you said you are using Python, people like, okay, what is Python, right? So really don't know, right? So, and people are using MATLAB and things like that. But within a span of 5 to 10 years, the tools have changed, right? So TensorFlow used to be really difficult to use about 3 years ago. You might have heard about this TensorFlow, but today it's actually really, really easy to use, right? So TensorFlow 2.0 was released maybe about 2 years ago. And things change very fast in the tools domain, right? So there are lots and lots of tools that come up and they change extremely fast. But techniques, on the other hand, they change at a much slower pace, right? So regression, classification. So these are techniques, core machine learning techniques, right? So core data science techniques. These techniques change at a slightly slower pace, right? So it took about 10 years for the support vector machine. So in the 90s, support vector machine was the most important technique that people were using for performing classification and many of the artificial intelligence tasks, support vector machine. And for about 10 years, nobody contested that support vector machine was the king of the field. Then it took another 4 or 5 more years for neural networks to really emerge. And from about 2006 is when this use of deep neural networks have started to become more and more popular. And in about 10 years, all right, 10 or 15 years, neural networks have matured and that has become the core, right? So it takes about 10, 15 years. That's the time scale in which techniques that are popular for a decade or so change. But behind all this is the fundamental concepts, right? So that almost always stays a near constant, right? So statistics, curve fitting, optimization, matrix algebra, all these are the fundamental, the base, the foundation of your building, right? So the foundation of your building stays constant for a much longer time. Right? So you can think of these constant or techniques as the fundamental ideas as the foundation of your building, the pillars, etc. Right? So the floors can be the different techniques that you build on top of that, and the interior, which you can change it just like that, right? So that could be like the tools, right? So don't get confused with the people saying, okay, this particular tool, do you know this particular tool? Do you know that particular tool? If you know the fundamental concepts and techniques, then tools are really, really easy to pick up. Right? So once the fundamental concepts are in place, techniques, tools are easily picked up, right? So this is the core of the learning process, right? So if you really want to learn data science, machine learning, etc., then you must build from the foundation, then start building the flows, right? So that's the analogy that we'll be using. So let's try to understand. So there's a lot of people who ask what is AI, what is ML, etc., right? So let's try to frame that in context. Where does AI lie? Where does machine learning lie? Where does data science lie, right? So let's consider data science universe, right? So the universe of data science lies here. Let's say this green blob is the universe of data science. Within that universe of data science, the first and most important thing is problem formulation. Like, what do you want? Like, what do you want to do, right? Do you want to predict the stock price for next week? Do you want to predict if Virat Kohli is LBW or not, right? So do you want to know if you have cancer or not, right? So this is the problem that you want to solve, right? So that is the problem that you want to try to address. Within this context, there are several tools and techniques that you will use. And one of that is machine learning. The other is data engineering. The other is Internet of Things. Now, everything is smart now, right? Your TV is smart, your fridge is smart, your phone is smart, your watch is smart, right? So everything is smart. So they are, what is smart? They are all internet connected devices that send and receive data. So that's what is called as Internet of Things. Then you might draw some inference from using the data, applying your machine learning, etc. And then you want to communicate that to your stakeholders, to your clients, right? So then you have to say stories in terms of data, right? So data stories are really important. Then you want to show nice visualizations of the data. So sometimes visualizations are really powerful, right? So you want to do that, and that becomes the data visualization aspect, right? So this is within the whole universe of data science. All of these are different elements that exist. Now, where does neural network come in? So neural network is one specific way of doing machine learning, right? So machine learning and neural network is one way of doing machine learning. It comes inside machine learning. Then to all this mix comes big data, right? So big data is really about having lots and lots of data. Now this big data intersects all these other aspects of the data science realm. And here you see where big data intersects with machine learning, and specifically where it intersects with neural networks. That is that small piece of this entire real estate space, right? So that small piece is where your deep learning lies, right? So deep learning is the application of deep neural networks, specifically using lots and lots of data, using big data. So it's a machine learning technique that uses lots and lots of data in a framework called as neural network to solve problems, right? So that is what deep learning is all about, right? So neural networks and deep learning that is where it lies. And where does AI lie in all this picture, right? What is artificial intelligence in all this, right? So data science universe has been defined. And in fact, artificial intelligence can exist with or without data, right? So if you just write a program that says if else condition, right? So if else condition, if you do, that is also an artificially intelligent program, right? So it knows what to do. But it does not need any kind of data to train that. So it's a rule-based system, right? So artificial intelligence can, in fact, exist outside the realm of data science. And usually when AI intersects with data science, that portion is what is called as the machine learning most often, right? So, and then a neural network is one such technique that in recent years have given a big boost to artificial intelligence. And then deep learning per se, right? So within that, where you use lots and lots of data to learn all these things, that's where this whole field rides, right? So data science, artificial intelligence, machine learning, neural network, and deep learning, right? So this is where it lies. And when we say computational data science, right? So data science is an umbrella term. Data science includes everything, right? So each and every part of this green circle is included in data science. Traditional data analytics. So if you are from the data analytics field, right? So traditional data analytics, this is related to modern data science, and you can consider it almost equal in meaning, but with several certain differences. And those differences mainly arise in the use of high performance computing devices like graphical processing units, using these high performance computing units to actually do computational data science. So if you perform all of this using high performance computing equipments, that is what is called as a computational data science. You can in fact do data science on Excel, right, on your piece of notebook, right? So if you draw a linear regression line, that is you doing data science. You're collecting data from a small experiment that you conduct in your lab, physics lab, or you observe that particular days the bus comes at 3 p.m., 4 p.m., right? So you observe that, and then in your heads, you construct a predictive model of when the time of the bus will be there, right? So all that is still data science, but you really don't need to use a computer to do that. So when do you need to use computers is when the scale becomes really big, right? So when you have lots and lots of data, when you have lots and lots of questions that you want to answer, and you want to answer this in a scalable and fast manner, that is when computers come. And if you do all these aspects of data science using this modern computing devices, that becomes computational data science. And that's what we are really teaching over here, right? So that's what this course is all about. Now, with that, another question that people ask is, why is data science important now, right? So where was data science all these years? Is statistics the same as data science? Is mathematics the same as data science? So why data science becomes important recently, right, over the last 10 years, is there has been a sudden explosion of data. I said everything is smart, right? Everything is internet connected device. Everybody, almost every family has more than 5, 6 mobile devices, right? So every person has at least 2 devices, 2 SIM cards, right? So these days, right? So these mobile devices generate a lot of data. There are cameras everywhere, CCTV everywhere, right? So there is traffic cameras everywhere. So all these cameras collect abundant amount of data, and the digital footprint of customers, right? So Google, Facebook, all these internet companies, they collect tons and tons of data, and that explosion of data has made it sure that you need to use computational high performance computing and all these major infrastructure to actually use that data and draw insights. And that's where computational data science and data science become really, really important. Right, so from this wheel, you can see the amount of data that is being generated in just 1 minute in 2019. Right, so one average minute in 2019 has generated so much of data. Right, so that is the amount of data that is available. That is what is making data science really, really important today. So I'll just give 3 quick examples on how specifically data science comes into practice. Right, so in finance, right, so banks. So you generally make predictive models to do real-time simulation of market events. So that is what one thing that you do. Fraud detection, right? So if you have a credit card, you swipe it in a particular supermarket or something like that, and immediately the transaction has to happen, right? So at that time, the credit card company has to decide if you are the one who is actually swiping it or there has been some fraud. So these days, you will immediately get a message saying that, okay, this particular transaction that you did is not typical of you, right? So there's a fraud detection thing that happens. That is a particular machine learning technique that they use to actually do that fraud detection. So you need machine learning in that, right? That's how the finance industry uses it. The other major thing is in lending, right? So if you apply for a loan and how they decide the EMIs, right? So equated monthly installments that you need to pay, right? So in many such cases, your data about what you do, what your age is, where you live, what is the kind of salary that you draw, all this data is put into a complex machine learning model that will then make the credit card company know if you are trustworthy or not. What is the interest rate I should give you or not, right? So all those decisions are also taken data-driven these days using machine learning, using tools like neural networks, right? Using all those tools, right? So that is one example. Another example that you know and which many of us are day-to-day we see is Hawkeye decision review system, right? So the decision review system that is used in cricket, right? So what it does is it's basically a predictive frame prediction problem. It's a video prediction problem. So they use high speed cameras to capture each and every moment of that ball and see how it will, once it hits the pad, how it will progress from there, right? So you need to actually make that prediction. And then today, according to today's capabilities, only half of the ball, right? So the precision is just about half of the ball. That is why in many cases it goes to umpire's decision, right? So that is because of the limitation in the camera imaging and the algorithms that are used to actually make those predictions, right? So that is all done using machine learning, convolutional neural networks, and predictive networks, right? So that's what is used. And here you can see Messi wearing some kind of vest. So this actually collects data about how Messi is running. And then the coach can make a decision about whether he should be called off and substitution should be made or not, right? So his pulse rate, all these things it measures. And then it goes into predictive models that classify whether he is fatigued or not, right? So that classification is done. So all these things are there in sports. And in another example that I will talk about, this is fresh from the research, right? So I was just working on this yesterday. This is the latest of the research field where we are actually using an autonomous underwater vehicle that has to go out. It has to find out if there is an enemy vessel that is present, right? So this is autonomous vehicle that comes out. It uses sonars, radars, vision cameras. It has different sensors that are there. And it has to actually see if enemy vessel is present. It has to go and observe what is the temperature in an ecologically sensitive area. All these things this autonomous vehicle has to do by itself underwater, right? So now it requires vision, computer vision it requires, and it also needs reinforcement learning, machine learning algorithm. So this is how you model this problem as a machine learning reinforcement learning problem, and then you try to find the optimal policy from it, right? So if you are interested, we have a paper published in that, and one more is being submitted. So this is just latest research from our group in IISc in using machine learning for several applications that you may not be aware of. The finance and cricket, maybe everybody knows that. So the final thing that we will discuss is why should you become data scientist, right? So this boom has been there for 5 to 8 years in the past, right? So 5 to 8 years, people have been talking about data science. But you might be surprised to know that in 2020, in a major survey that was conducted in the Fortune 1000 companies, and the theme of the survey was data-driven business transformation, connecting data investments, right? So investment these companies have made to business outcomes. Are they connected? This is what they were trying to do. And you might be surprised to find that in most of these big companies, right, investment in big data and AI has kind of leveled off, right? So almost 99% of the companies said they have already invested, right? So they're not increasing their investment, right? So it's leveling off. But only a very small fraction has actually put AI in production and use AI and data science in their business process. And so people are trying to find out why, right? So we need to answer the question why in order to progress. And what most of them said is that they don't have a data culture, right? So only 27% of the companies actually said that they have successfully built a data culture. So that what do we mean by culture? It's people and business processes that there are no data scientists available. The people who are working on the domain don't know about data science, how to use the data, how to leverage the data. They are not aware of that. In most of the cases, technology was not a challenge. The tools were not a challenge. Tools, technology, everything was available. It is people who knew how to use data science. That was what was missing. And so this was from a major survey. This is, in fact, in companies, this is what is called as the viability gap, right? So from theory to practice, right? So the gap, right? So usually this is called the innovation valley of death. So people know, people have invested in data infrastructure. People have invested in, companies have invested in data infrastructure. But to go from proof of concept to a minimum viable product, right? So that portion is what is called as the gap, innovation valley of death. And to bridge this innovation valley of death, we need data scientists, right? So we need people to champion, people who understand how to build data products and take it out. And that is exactly where our course comes, right? So this is the need for data scientists, new data scientists with knowledge of all the concepts, techniques, tools, and domain. Domain is what you bring, right? To this course, you bring your domain knowledge. We will tell you about concepts, techniques, and tools in the data science domain, starting from the mathematics, the foundation, going up to building the different floors, right? So including machine learning, neural networks. Then we will top it off with applications, case studies from the business, right? So business analytics, how to use these